Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 7.1, day 2, entitled Trigonometric Identities. And today we're going to prove trig identities. And what that means is they're going to give us an equation now, basically. So we'll have to simplify one side of it and prove that it is equal to the other side. And we're still going to use our algebraic techniques that we've been using, and we're still going to use our knowledge of trigonometry in order to do this. And basically, when you have an equation, we're trying to say that the left-hand side is equal to the right-hand side in any equation. So here, if we have sine x plus cosine x equals 1, if we substituted in a value, let's just say pi over 4 for x, and if we tested it out, sine of pi over 4 is square root 2 over 2. Cosine of pi over 4 is also square root 2 over 2. But when you add those together, you get the square root of 2. You don't get 1. So that equation's not true. So this is what we're going to do with our trig equations today. We're going to start with one side and simplify it as much as we can, and hopefully it simplifies down into the other side. Now you want to start with the most complicated side. Usually I say start with the left-hand side and see if you can simplify it to equal the right-hand side, but that's not always the case. You could start with the right-hand side and go to the left-hand side. And we're going to use our trig identities and our Pythagorean identities and our knowledge of algebra. So we're going to be doing lots of work with fractions. We're going to be taking out a GCF. We could factor. All of that knowledge that we've been using in the previous day of notes, the 7.1 day 1, we're still going to apply that today. And when in doubt, see if you can convert either side to sines and cosines. Because sometimes when you're given a lot of different trig functions, it's complicated to see how it's supposed to simplify all the way down. So if you can convert everything into cosines and sines, that might help you start working on that simplification process. Okay, so we have 3 examples, and this is our first one. And for part A, we're just going to verify that this equation is an identity. And when they write it that way, that just means to prove or show the work that shows that the left-hand side is equal to the right-hand side. So in our equation here, we have cosine of theta times secant theta minus cosine theta equals sine squared theta. So I want to start on the left-hand side, and I want to prove that that's equal to sine squared theta. Okay? So we definitely want to start with the most complicated side, and the left-hand side is the most complicated looking. The right-hand side only has the sine squared, so that's doesn't give us a lot of options to work with there. The left-hand side has way more terms, so we have more to work with and help us simplify it and rewrite it. So the first thing I see is that I have cosine and secant and cosine. This secant is kind of a little oddball. So I'm going to rewrite him because secant is really 1 over cosine. So for part A here, I'm going to take my cosine of theta, and then instead of secant, I'll write 1 over cosine theta minus cosine theta. Okay. And now I could multiply these. If I multiplied or distributed that cosine theta to both terms, then I would have cosine theta over cosine theta minus cosine squared theta. And cosine over cosine is 1. So now I have 1 minus cosine squared theta, which is actually a Pythagorean identity, and it's equal to sine squared theta. And that is what I had on the right side of my equation there. So since those match, then I proved that this equation is an identity. Okay, now part B says that we need to confirm graphically that the equation is an identity. Now, if we were to do that, we would have to put the left-hand side into the graphing calculator for y equals, and put the right-hand side into the graphing calculator for a different y equals, and then graph them and see if it's actually the same graph, see if they match. And that's the picture that you would get if you did that. Now remember, when you're typing secant into your calculator, you need to write it as 1 over cosine when you put it into your graphing calculator. Okay? But that's basically how you would confirm graphically that the equation is an identity. You want to see that the left-hand side and the right-hand side give you the same graph. Okay? Now, we could have started that problem by working on the left-hand side. We could have changed the sine squared theta into the 1 minus cosine squared theta, but then it's kind of hard to know where to go from there. Like, how did they get the 1? Was it cosine over cosine, or was it tangent over tangent? So definitely starting with the most complicated side and going to the right hand, or yes, the right hand side, the simpler side, is probably the best strategy. Okay? Now in the next two examples, I'm going to show you some other strategies that you can use. And here we're going to use multiplying by the conjugate. And if you remember that from your algebra days, that's where you multiply by whatever is in the denominator, except you change the sign between the two terms. So if you look at this identity here, we have cosine of u over 1 minus sine u equals secant u plus tangent u. Now, you might be able to argue that either of these sides looks more complicated. Okay, on the right-hand side, we have the secant, which we could change. The tangent is really sine over cosine. Secant's really 1 over cosine. So we could rework that side. That's got room to work. But I would say that the left-hand side is more complicated because it's got a fraction. Okay, so we're going to start working with that side. And I'm going to get rid of the fraction because the right-hand side does not have a fraction. So I have to get rid of that 1 minus sine u. And how I do that is I multiply by the conjugate. And remember, what you do to the numerator, you have to do to the denominator. Okay? So that step right there is the multiplying by the conjugate. Okay, so now in my numerator, I'll have cosine of u times 1 plus sine u. I'm just going to write it as multiplication for now. I don't know if I'm going to need to distribute the cosine in or not, so I'll just leave it for now. In the denominator, then I'm going to FOIL, basically. So I'll have 1 plus a sine u and then minus a sine u. So those are going to cancel each other out. And then I'll have minus sine squared u. Okay, now hopefully you're getting used to seeing the 1 minus sine squared u or the 1 minus cosine squared u and realizing that that's your sine squared plus cosine squared equals 1 Pythagorean identity. So I'm going to leave my numerator, but in the denominator I can rewrite this now as cosine squared u. Okay, now here's usually where students are like, I'm not sure what to do next. But look at this as if it was a fraction with a term out front and a term in the denominator. You know that those two terms are able to be canceled if at all possible. And hopefully you see that one has a cosine and one is really two cosines. This is cosine times cosine in the denominator. So I can cancel out one of those cosine u's. So now in my numerator I just have 1 plus sine u. Now, hopefully you would still be able to see that if you had distributed the cosine u here, if you had multiplied it. But technically, in order to cancel, you'd have to factor it back out like a GCF and then cancel. So it's good to maybe hold off on the distribution until you know you really need to do it. Because here, since I waited to distribute, then I was able to cancel the numerator with the denominator. Okay, now this is a step that we saw in the previous section of notes where I have one fraction. It has two terms in the numerator, so I'm going to break them apart. So I'm going to have 1 over cosine u and sine u over cosine u. So now I can see each individual little piece and I can say, oh, 1 over cosine, that's secant. And sine over cosine, that's tangent. And now I've completed my identity because I've made the the left-hand side equal to the right-hand side. So there's a lot of strategies that are being applied here. We're multiplying by the conjugate. We're canceling out like terms. We're breaking apart big fractions into smaller fractions. So all of these are algebraic concepts that we need to apply with our trig identities now. And we used one of our Pythagorean identities as well. Okay. All right, now this last one shows another step or another strategy for how you can simplify an identity or verify an identity. And that is to start working with one side, and sometimes you work with it and you get to a point where you're just kind of stuck and you don't really have anywhere else to go. So when that happens, then go to the other side of the identity and see if you can simplify that down to match the point where you got stuck on the other side. And if that happens, as long as the left side and the right-hand side are equal, then you've proven the identity or verified it. Okay? So I'm going to start with the left-hand side again. Now both of these are pretty complicated. They're both fractions. Here I've got tangent and secant. Here I've got 1 plus cosine. Okay, but hopefully if you look at this left-hand side, you see that you have two terms in your numerator and it's over one denominator. So hopefully when you see that now, you're beginning to realize, oh, I should probably break those apart. And that's what we're going to do. I'm going to have 1 over cosine and then cosine over cosine. Okay. Now when I do that, the 1 over cosine I can write as secant. And the cosine over cosine, that's 1. But now I'm kind of stuck. I don't know what secant plus 1 is. There isn't much else that I can do with secant plus 1. So now I'm going to jump over to the right-hand side, and I'm going to start simplifying this side. Okay. Now tangent squared theta, hopefully you know that that's one of our Pythagorean identities, and it's equal to secant squared minus 1. So I will rewrite that. That tangent squared, I'll rewrite that. Now, here's kind of the trick, another trick that we can apply on the right-hand side here. This secant squared minus 1 is really, really close to being a secant minus 1. If only that squared wasn't there. Now, sometimes students say, oh, just take the square root. Well, I can't do that because they're attached with subtraction, those two terms in the numerator there. But how I can get rid of that squared and be able to cancel some stuff is through factoring. So I'm going to factor that numerator. So think of this as like x squared minus 1. Instead of secant squared, just make it x squared. If I was going to factor that, I would use guess and check, or you would know this is a difference of two squares. You have x and x, and a 1 and a 1, and one has to be plus and one has to be a minus. So that's what I'm going to do here, except I'll have secant theta plus 1, and then secant theta minus 1. So if I were to FOIL this out, I would still get my secant squared. Then I'd have a minus secant theta and a plus secant theta, so they would cancel. And then a 1 and a negative 1 get you a negative 1. Okay? So you can factor trigonometric expressions just like you would factor a quadratic expression. And now the nice thing is that now I have a term that'll cancel with my denominator. I have a secant theta minus 1 and a secant theta minus 1. So those cancel, and I'm left with a secant theta plus 1. So again, I'm kind of stuck, but I have gotten to a point where the left-hand side and the right-hand side here are equal to each other. So there we go. I'm done. I have verified my identity because I got the left-hand side to equal the right-hand side. So this strategy is a little more complex. You don't see it as often, but know that it is able to be used and that it's legal. So if you start simplifying one side and you get to a point where you're a little stuck, start simplifying the other side and see if you can get it to equal to the point that you got stuck at on the other side of the equation. Okay? So we're still going to be using our algebraic skills. We're still using our trig identities. Okay, so make sure that you write this all out. At least now you know what the other side is supposed to be. So if you're starting with the left-hand side, you know what's on the right-hand side. You know what you're supposed to get it equal to. So sometimes students find that helpful. You're going to be doing 29 through 89 every fourth. So that's like every other odd problem. And since they're odds, you can check them in the back of the book. But remember, the work is all worked out in the binder in the classroom as well. And if you have any questions, come on in and see me before school.